Hey guys, how's it going? So I have another question in Calculus 3, also applicable to linear algebra, that involves vectors. The question goes like this. The magnitude of a velocity vector is called speed. Suppose that a wind is blowing from the direction 45 degrees northwest at a speed of 50 kilometers per hour. A pilot is steering the plane in the direction 60 degrees northeast at an airspeed of 200 kilometers per hour. The true course or track of the plane is the direction of the resultant of the velocity vectors of the plane and the wind. The ground speed of the plane is the magnitude of the resultant. Find the true course and the ground speed of the plane. Let's highlight this and round your answers to one decimal place. So this was Scott from an assignment. It's perfectly usable. Let's go. So first of all, the first thing you need to know is that when you're adding two vectors, the resultant is the sum of two vectors. So when you have a vector A and a vector B, you take the head of the first and connect it to the tail of the second, and the resultant goes from the tail of the first to the head of the second vector. Sorry about that, which is the C, which is equal to A plus B. So that's just a little summary on adding vectors. So let's first draw these vectors. Okay, so 45 degrees northwest at a speed of 50 kilometers per hour. That looks something like this. I'm going to write 50 here. 45 degrees northwest looks like that. So that theta is 45 degrees. And we want the resultant. So we're going to add the direction the pilot is steering at. So 60 degrees northeast, 200 kilometers per hour. So let's take the tail of the second and combine it to the head of the first, which gives us something like this. You should probably label 50 and 200 since your diagram most likely won't be to scale. Yeah, and your results. RES for results. Now, this is 60 degrees northeast. So this from here to the positive axis is 60 degrees. Now, this is all we're given, but here's a trick. This is 45 degrees. You do like sort of like a rotation style. And this side is also 45 degrees. Because it's like 45 degrees here. So on this end, it's also 45 degrees. Yeah. And 60 plus 45 gives you 105. So your angle here is 105 degrees. So let me just erase this part and that's 105 degrees. We want our resultant, we want our, let me think, we want our resultant vector. This resultant vector will be the ground speed of the airplane. So let's use the cosine law to find this ground speed. RES, let's call this vector C. These are just arbitrary values for A and B. So C squared is equal to A squared plus B squared minus 2AB cosine C. And that is equal to 50 squared plus 200 squared minus 2 times 50 times 200. Cosine C, with cosine C 105. It's always the angle adjacent to that line. So yeah, 105 cos 105 degrees. And when you add that up, let me just use my calculator here real quick. Plus 200 squared. We're typically not allowed calculators on tests, but like the homework, like we're allowed calculators. Besides, it said round to the nearest like one place after the decimal anyway, so it's fine. Cos 105. When you get that, you get an answer of 47676. That's c squared, but square root this answer, and you get 218.35, roughly 218.35 kilometers per hour. I used 218.3 in my answer, and it was correct. So anyways, that is the first part. That is your resultant. Resultant ground speed. Okay, now we need to find the true course. The true course will be the direction of our ground speed, which is this big theta right here that I'm drawing. Okay, so how do we do that? We need to find out what this angle is, this B angle here first, before we do that, and you'll see why. Okay, so we now use the sine law to do that. B over, okay, so sine B over B is sine C over C. And let's just plug the values in. So sine B over 200 is equal to sine C. Let me think. Yeah, sine 105 degrees over 218.35, because that was the value of C right here. And that roughly gives you sine B is equal to 0.88. And when you, I already calculated this in advance. Feel free to use a calculator if you like. And when you take the sine inverse, B is equal to, what was it, 0.8. Hang on. 200, okay, let me, 0.89, wait. Wait, I'll be right back, guys. Sorry. Sorry, guys. I was looking at the wrong thing for a second. I was looking at a different question, but anyways, here we are. It's 0.88, and that means this angle B, when you take the sine inverse, you get 62.2 degrees. Okay, now here's where we can solve. So A and B and theta make a straight like line, kind of like this, A, B, and theta, A, B, and theta. And these three angles will add up to 180 degrees. Well, we know A is 45 degrees. Put the degrees on there, by the way, otherwise they'll think it's radians. 62.2 plus theta is 180. And when you do it, let me just get my calculator real quick. You get an answer of 72.8 degrees for theta. So the answer, the true course is 72.8 degrees northeast. Because it's like northeast, yeah, here, yeah. And that is done. You are done the question now.